Today we're going to talk about what a resistor is and how to calculate the total resistance in a circuit. So what is a resistor? It is anything that resists or restricts flow of current and converts electrical energy into usually thermal energy or light. So we have a circuit on the left, and that is what a simple circuit with a resistor is going to look like. The squiggly line is going to be a representation of what a resistor is. On the right here, we have a circuit with a light bulb, and I'm just trying to show you that a light bulb is also a resistor because as the current goes through that light bulb, that electrical energy is first turned into light, and if you leave that light on, you can feel that the light bulb is getting warm, and that is electrical energy turning into thermal energy. So now we're going to go in to talk about the different combinations that you can put resistors in. One way you can put resistors in is in series. I have two examples for you in these two already drawn out circuits. The circuit on the left side, you can tell that it is a resistor in series because you're going to go from the positive end and you're going to follow the flow of electrons, and you're going to go through that 4 ohm resistor, and then as you continue on you're going to also go through the 6 ohm resistor. So resistor in series is when electrons have to go through one or more resistors at a time. So I just wanted to show you that even though the circuit on the right is drawn a little bit differently, it is still in series because as you go through that circuit, you're going to have to go through the 2 ohm resistor as well as the 3 ohm resistors before you have to you can go back to the end. Before I move on, I just want to talk about how I think of resistors, and I think of resistors as stop signs in traffic. So, like I talked about with resistors in series, I like to think about resistors in series as one road with 2 stop signs. And so that's not a very effective way to get through because a car is always going to have to stop at the first stop sign and then speed up and then have to stop at the second stop sign before they can keep going. In contrary, if you have one road that splits into 2 and there's a stop sign at each road, each car that makes it to the end only has to go through 1 stop sign. And so that is a representation of what a resistor in parallel is going to be like, and we'll talk about that later. But as you can tell, resistors in series, like the top picture, is going to have a lot more resistance than resistors in parallel. So how you calculate the total resistance in a circuit when the resistors are in series is using this equation of R effective equals R1 plus R2 plus R3 and so on. So for the circuit on the left side, if we follow the circuit, we're going to go through the 4 ohm resistor, and then go through the 6 ohm resistor. So that R effective is going to equal 10, as well as on the right side, it's going to be the 2 ohm resistor plus 3 ohm resistor, which equals 5 ohms. Okay. So resistors in parallel. A way I am able to figure out if resistors are in parallel is starting from the positive end, and then you're just going to go up and follow a path, and you're going to be able to see that electrons flow can split into 2 paths. And so one path is going through this bottom 2 ohm resistor, and then the second path is going through that 2 ohm resistor on the top. And so contrasting from resistors in series is that one singular electron does not have to go through 2 same resistors, but they go through 2 separate resistors. So on the left side we have 2 resistors in parallel, as well as on the right side we have 3 resistors in parallel. And so how you calculate resistors in parallel is using the calculation of R effective equals 1 over R1 plus 1 over R2 plus 1 over R3 and so on, and taking the inverse of it. So for the diagram on the left, the R effective is going to equal 1 over 2 ohms plus 1 over 2 ohms, which is going to equal 1 ohm. And then you're going to take the inverse, which is also 1 ohm. On the right side, we can take 1 over 6 ohms plus 1 over 6 ohms plus 1 over 6 ohms, which is going to equal 3/6 ohms. And taking the inverse of that would be 2 ohms. From here, we're going to learn how to simplify circuits, because not all circuits are simple as just parallel or series resistors. And so how I like to do simplifying circuits is to do the same thing that we've always been doing, is starting from the positive side, and then we're just going to follow one path. So for example, this first time we're going to go all the way to the top, and we're going to go through that 2 ohm resistor. And then as we continue, we get to a cluster of resistors, and it looks like those resistors are in parallel because you can have 3 different paths. And so we're going to first put all those together. So since they are in parallel, we're going to be able to use the 1/3 plus 1/3 plus 1/3, which equals 1, and then you're going to take the inverse, which is also 1. So this whole thing is going to equal 1 ohm. So with the top one, we can also put them together because you have to go through the 2 ohm as well as the 1 ohm resistor to go to the end. And so we know that that is going to be resistors in series. So 1 plus 2 ohm is going to be 3 ohms. And so on the right side is that top bar is going to be a total resistance of 3 ohms. So now we're going to go through a second path and go through that middle line. So as we go through that, we have 2 options. We can go through the top and go through resistor of 3 ohms, or you can go through the bottom side and go through 2 resistors. Since we have to go through 2 resistors, we're going to add those together because those are in series. And so 1 plus 2 ohms, so that's going to be 3 ohms. But now that we figured that out, the 3 ohms resistors are going to be in parallel, so we're going to have to do 1/3 plus 1/3, which equals 2/3, and then take the inverse, and that is going to be 3/2, or 1.5 ohms. So now that we know that this is pretty much 1.5 ohms, as we follow this path, we have to go through a second resistor, and so we know that those are in series. And now how we add those together is just 1.5 ohms plus 1.5 ohms, which equals 3 ohms. So over on the right, we're going to see that it's 3 ohms on that middle line as well. And then nothing happens to the bottom one, so it continues to stay 1.5 ohms. So that is a lot more simplified than the original circuit. And so we're going to just simplify this even more. So as you go from the positive to negative, you see that the 2 3 ohm resistors are in parallel. And so what we can do is 1/3 plus 1/3, which equals 2/3, and take the inverse, which is equal to 1.5 ohms. And then if you go through those top 2 and you go through 1.5 ohms, and then you have to go through the 1.5 ohms at the end, you know that that is in series. So 1.5 ohms plus 1.5 ohms is going to equal 3 ohms, and 3 ohms is going to be your total resistance in this complicated circuit.